class that you get. I'm going to show you why it's important to lock down devices in a certain manner, and if you don't, the bad things that can possibly happen. So, I'm going to cut the lights here. Use the front light here. So, with your device security policies, you want to think about this from a vantage point of security rings. Right? So, multiple layers of security, very important, especially for infrastructure. Okay, critical infrastructure. So, the first ring in that defensive perimeter is your physical ring. How do I lock down the physical aspect of my equipment? All right? Do I have my routers, my switches, my firewalls, my access points easily available for individuals to get their hands on? Or do I have them in a locked cabinet, in a locked data center where I have to have two pieces of material in order to get into the data center, like maybe a key or a card or a biometric scanner of some sort, all right, fingerprint scanner, hand geometry, okay? Or do I just have it like sitting on a bread rack somewhere that anybody can open up the janitor closet and get into my switch? Okay, seen all types of physical security on infrastructure equipment from those two extremes. Okay, you'll have to have a certain perspective on this when class is done tonight. So if you work in the field, if you work in IT, think about how your equipment is secured from a physical perspective, especially once I'm done. Port level security. Your virtual terminal lines, your communications port, your auxiliary port, those are very important to lock down as well, from a physical perspective as well as a virtual perspective. Virtual being protocols that I can get into it via, like Telnet, SSH. Keeping IP under control, and especially TCP under control. I'm going to talk about securing FTP and HTTP tonight. I'm also going to talk about why we need to use SSH instead of Telnet, and run through an example to show you why we use SSH instead of Telnet. Okay? So locking down ports. Device hardening is all about locking down the methods of accessing your devices. Your virtual terminal lines, your communications port, and your aux port. Your virtual terminal lines is how we would get to it via IP, Telnet, SSH, okay, HTTP, all right, or any means thereof. A COM port and an aux port is how we're going to physically access the device via an RS-232 rollover cable. Okay? Depending on whether A, the port is active and live and allowing connections, okay, and B, can I actually physically touch the device? If I can physically get my hands on a Cisco device, router, switch, firewall, access point, what have you, I can break into it, okay, 99 times out of 100. There's that one time that I won't be able to break into it, but if I can still get my hands on it, I can probably still break into it. You just have to know a couple of secret handshake things, I guess you could say. All right? Password policies are very important. We're going to talk about this tonight, of how we secure passwords. Now, we can have, very strong password policies within our organization. 23 characters, alphanumeric, capital, letters. We can have, special characters. Great. If you're not securing the password itself, doesn't matter, and I'll show you why. Username and password pairs. It's very important that these are locked down as well within the device configuration. If you're using passwords on your virtual terminal lines alone, okay, that's not as strong as if you use username password pair. because you go from one factor of authentication to two factors of authentication. Okay? But you have to control how the passwords are managed. And that's done through security levels. Okay? We're going to talk about the 3 different types of security levels of passwords within Cisco iOS. 0, which is plain text. Level 7, right, which is an encrypted passwords, basic encrypted passwords, and level 5, which is actually uses an MD5 hash. Default services. We have to turn off many of these default services that we don't need. Okay, because one, they take away from your environment. They can take up memory, they can take up CPU cycles, and they are a window into your device. Okay? If you are not running anything that you need the HTTP engine or HTTPS engine for, turn it off. If you have a router and you're running Call Manager Express and it's your phone system and your voicemail system, okay, I can see why you would need that. Maybe if you were a beginner, a novice at administrating it. I can manage a Call Manager Express from the command line. Okay, I've been working with it for, gosh, going on 7-8 years now. All right, I'm comfortable doing that. Somebody that's just starting out, yeah, you want to do the GUI. Telnet. I fight with engineers all the time. Telnet's easy to set up. Nobody's going to sniff my packets. I don't care, you know. I don't have to worry about RSA keys or you know, stuff like that. Telnet's fine. Wrong. What do you want to use in place of Telnet? SSH. Why?
You're going to show us.
I'm going to show you. There's a reason why. It's encrypted. Same with FTP. You don't want to use FTP or especially anonymous FTP. You want to use SFTP. Again, it's encrypted. And I already talked about the 3 different types of passwords. I'm not going to rehash that. Password encryption. Setting up password encryption is used with the service password-encryption command. It is set and turned off by default. So if you looked in a show run, you'd have a no in front of that command. All right? Securing the BIOS. Now, this is that 1% of the time that I might not be able to get into your device. All right? If you have it locked down. It depends on the device and depends on the software. But if I go into Ramon, which is the BIOS of a router or switch or firewall, I can set this no service password recovery, meaning I cannot do a break sequence at reboot, drop down to Ramon, manipulate the file system, and break your password or reset your password to default. Okay? If I do that. It's not impossible to recover from because a lot of Cisco's architecture, especially on the new 2900 series, 3900 series, some of the 6500 series supervisor engines, there's a jumper. All you gotta do is pop that jumper, wait 5 seconds, put the jumper back on, reset it, and you can break that sequence, or use the break sequence. User accounts in iOS, I'm going to talk about how we create users, create passwords for those users, the privileged exec commands that we set for those users. All right? And it's really good to look at the example on 3.1, page 61, especially for the question on your lab on setting the different privileged exec levels up. I'm going to talk about how you lock down your virtual terminal lines. Okay? Setting a password is a simple way to do it. But again, not as effective as if we were to make users and make you log in as those users to the local system. Okay? Make it even more effective if we authenticate those users via an outside database, like an Active Directory or an LDAP directory. We get into that later on when we talk about AAA. Common aux port security. Still set passwords on these ports. I'm amazed at how many times I go to customers and they have the COM port and it's just wide open. No password whatsoever on it. Like, And I can get into the janitor closet and console in, and I'm now in your network. Aux port is primarily used for modem support, out-of-band management, dial back. If you don't have that set up, turn it off. You don't need it. You have a common port. Okay? But the aux port is really good if you have a 9600 baud modem for out-of-band management, meaning I can dial into a network via the PSTN, gain access to that router, and administrate that router out of band, meaning out of wire connection. Okay? I can set modems up for dial back, okay, or reverse telnet, meaning I can set a list of phone numbers to accept calls from. It can inspect that list. Okay? And even if somebody were to spoof caller ID, manipulate DTMF tones, okay, I can still have a fail-safe to where I cut the connection and then I call the number back. I call the number back. So there's a fail-safe mechanism for reverse telnet as well. Banners. Banners are good. I like banners. They're not that hard to set up. There's a command for it. Banner, whether it's a login banner, an exec banner, and message of the day banner, and then you set a ending character. It's a good last line of defense deterrent to put a login banner on your system. So you can tell the person, if you are not authorized to be on this system, you should not be on this system. And oh, by the way, I'm logging everything that's going on onto the system. I will find you. I will hunt you down. I will throw you in jail. Yes, I do have that on my equipment. We'll get to that later on when I talk about my home wireless network. Securing the boot image. Cisco iOS resilient configurations. Secure boot image enables and secure boot configs is used for copies. It is used for encrypting the boot image and encrypting the configuration files. It hardens the running and startup configs in ROM with the primary boot set. So it has to be done on your onboard flash. Other services that we're going to talk about tonight, some of them, Cisco Discovery Protocol. We're going to look at how we lock that down. We're going to talk about DHCP and configuring that. TFTP and FTP. You use TFTP a lot for file transfers, especially when you're doing backup. And it's very, very important that when you do use this, you have your passwords in your configuration encrypted, and I will show you why. And also, auto-loading commands. You want to ensure that you, if you have them, you have the correct files, and you look at those and you inspect the hashes of those files on a somewhat regular basis to make sure they've not been changed. ARP, proxy ARP, gratuitous ARP. We'll get into that later when we get into layer 2 security. IP directed broadcast, direct redirects, mass replies, ICMP unreachable, ICMP echoes. These are interface commands, and they go through this in chapter 3 in quite detail, that you want to try to put in order to manipulate ICMP, Internet Connection Message Protocol. Because ICMP can be quite nasty. You can gain a lot of information, reconnaissance information about a network through ICMP. I already talked about HTTP. We'll get into SNMP later on. SNMP is off by default on network infrastructure equipment. And if you turn it on, you want to be very careful. You want to use typically SNMP v3 if you can, or at least SNMP 2C. I already talked about the HTTP engine. I'm not a fan of it. And finally, the auto secure feature. On page 75, you'll find the commands to enable the auto secure feature. And this is a relatively new command that will go through a lot of the security hardening steps that I talked about already on your device. You just have to be very careful that of how you set it up, because it's going to go through a scripted question list. I suggest that you try it in GNS3, see how it works, okay? And you can look at some of the things it turns on and turns off. Hold your questions. I'm going to go through some of the demo pieces from tonight. I'm going to go through configuration of Lab 1. And some of the, well, geez, why do you do that, Professor Brown? So, let's open up GNS3. And what I've done here is I've created when I open it up, I created a project. Right? So, once you create a project, you have that box that opens up. You should select both of the check boxes, give it a name. That's going to open up a folder. Alright, I have mine in temp. Lab 1 sample. That's where my folder is. That's where my working configs are. My saved configs will go. So I'm going to use Lab 1, R1, Router 1 as the example for Lab 1. I'm going to walk through Lab 1 here. Okay? So, how do I get into privilege exec mode? Enable. If I do a show run, you can see that I have done a clean write erase. I'm on a clean config. So question 1 is to create your router, console to it. Ensure it has 2 10, 100, 1000 interfaces. And question 2 is give it a host name. So it has 2 fast user interfaces. Put it in GNS3. To do any commands, I have to go into global configuration mode. What's the command to go into global configuration mode? Conf T, config T. Alright, my prompt changes. To change my host name from router to R1, it's simply host space R1. See, we're already 20% done. Now, I'm going to make one user here. I'm going to make the root user. Okay? Root, password, root, privilege level 15. So, to create a user, just type in username, the user's name, root. Okay, the privilege level, which in this case it's privilege 15, and then the password. So password was root. Very good. If I ever want to look at the running config to check my work, I don't have to back out of global configuration mode. I can simply type the do preemptor, do show run. And you can see there's that command I told you about, service password encryption. It's currently turned off. I know it's turned off because it has no in front of it. There's my user. My password is root, because my password is set to clear text. That's what that 0 means. Okay? Alright. Step 3. Alright, step 4. We want to set one interface to 192.168.20.1. So I'm going to make that my topology here. That's going to be Ethernet 00. So interface F00. Put the IP address in. It's IP add 192.168.20.1 and the subnet mask, which was 24 bits. Okay? So IP space add space 192.168.20.1, 255.255.255.0, enter. Now I have to do what to the interface? Yeah, and that does what? Turns it on. Good. I'll get the message that the link came up. And now I can move on to question number 5. Set your other interface to 204.186.29.29/30. So I go to int f01, add 204.186. 30-bit 7-bit mask is 255, 255, 255, 252. Again, turn it on. Shut. Now, I'm going to do one other real quick thing here on R2. I need to put the other end so I get that connection. Ping the other side. Yep. So I now have connection between R1 and R2. Good.
So you do the same thing on both of them?
You don't have to do R2 at all.
Oh.
Okay, I'm just gonna. That's very key to my example later on. So I just want to make sure I have connectivity. You don't have to worry about doing all of these on R1. You only have to do R1. Yeah, absolutely. I only want the config for R1. Don't send me 2 configs for Lab 1. Trust me, you'll have plenty of opportunity later on in the course to do multiple routers, firewalls. It's coming. All right. So, you just set a default route to 204.168.29.30 on R1. So, to set a default route, okay, last time around, I talked about setting up OSPF. OSPF is a dynamic routing protocol, and it allows the routers to learn about routes based on the networks that you program, that you tell the router, these are the networks you're managing. With static routing, you have to basically build your routing table from scratch. Well, what a default route does is it allows you to create a route to the internet. Because you would want to put, millions of routes to everywhere on your router that point out to the internet. If you can just put one out there that just says, okay, if you don't match anything in my routing table at all, go this way. There are dynamic routing protocols that work on the internet, primarily BGP, but 90% of the networks that are out there, the public networks and the private networks, home user networks, small company, medium-sized businesses, they don't run BGP. They're not big enough to. So they just have a default route to their ISP. The command to put that in is IP space route space 0.0.0.0 space 0.0.0.0 space the next hop IP address, which is that right there, 29.30. Now we're going to set up the DHCP portion. Okay. I have a couple commands I have to. I have to set up my DHCP server. All right. I have to set up the DNS servers that are going to be given out when a station requests an IP address. And I have to set up an exclusion so that the DHCP server does not serve up 1 through 25. So how I do that is I'm going to do my exclusion first. IP DHCP excluded dash address. Beginning IP address, space, ending IP address. Sorry about that. Okay. The next step is to create the actual pool of addresses. And how I do that is IP DHCP pool, and I give the pool a name. Alright? I can give it whatever name I want to. It's arbitrary. So I'm just going to call it Lab 1 Pool. I have to tell it what network it's working with, what network it's serving IP addresses out of, which is the 192.168.20 network. And its subnet mask. If I put the network command in there. So it's network, the network number, the subnet mask number. Network, network number, subnet mask number. And finally, I define its DNS servers, which are 192.168.20.16 and 204.186.20.53. DNS-server 2.168.20.16. 204.186.20. Now if I look at the running configuration, you see that I have the excluded address and the pool. That's probably the hardest part of this entire lab. Now I want to set up a standard access list on your router and deny traffic from the 117.23.54 Class C network. Now, I didn't say where you had to add this. I don't care where you add it. It doesn't matter, as long as it's added to some interface, inbound or outbound, with an access group command. I'm going to add it to the inside interface, my F00 interface, inbound. We'll just say it's a site that I don't want my local users to go to. So how I do that is I want to type in access list. I want to use a number 1 through 99, which is for a standard access list. I'm just going to use 10. Deny 117.23.54. .0. And do I use a regular subnet mask or a wildcard mask? Wildcard mask, right? You always use a question mark. It'll tell you wildcard bits. 0.0.0.255. Now, after I put a deny statement in, and I create an access list, before I add it to my interface for inspection to deny traffic, if I'm setting it up this way where I'm denying a specific space, what do I have to put in next? A permit. Otherwise, I'm going to deny everything, right? Because there will be an implicit deny after that. Please keep that in mind. So, access list 10, permit any. Now I'm going to go into my Ethernet port right here, which is F01. And type in IP access group 10 inbound. Okay? Very important you put this in on the interface, If you don't, you will lose 5 points. If you miss this and you don't put the permit in, I may take off